Here we are back at Automate Day 4. We're at the SICK booth and they're going to show us some advanced 3D safety technologies. This is something that's super cool. Generally, safety has been done with like 2D laser scanners, light curtains, things along those lines, but now we're starting to be able to get into a world where we can do 3D type of safety systems. And he's going to explain to us, this is Nick here with SICK, he's going to explain to us a little bit about this system, how it's working, and some of the devices and things that it takes to make this system actually work.
Well, hi, my name is Nick Kern. I'm a systems application engineer with SICK, and today we're showcasing a new form of dynamic safety. So unlike your traditional needs for safety fencing, caging, any 2D area scanners, our partnership with Sensory Robotics can create a 3D bubble which actually follows the contour of the robot. You can see if I go to try and touch the robot, it'll stop, and as I leave the scene, it'll resume operation again. What we're showcasing with the system as well is our 3D robot guidance. We take our 3D vision here to locate our Legos and pick up. Also demonstrating that color does not matter in 3D imaging. Back to the sensory system and safety. What's cool about the system is it's robot agnostic, and we can track multiple robots at the same time. Definitely a new advancement in the industry for safety, allowing us to collaborate with industrial robots or cobots as they exist.
And how he was saying, you can pair this with multiple different robots. So if you can see like the screen in the background, you can see where it's following the robot around and how that point cloud is basically moving with the robot. So that way, I'm not sure if I can do this very accurately, but like the safety system is now actually, it's moving, right? So it's only protecting this bubble of the robot. And so if I put my hand here, maybe it's okay for the robot to start coming over, but after it breaches where my hand's at, where that safety bubble is, that's when it'll then trigger the safety signal telling the robot to stop. And for this technology, you're using LiDAR type of vision cameras?
Correct. So SICK builds the 3D time-of-flight cameras, which are LiDAR. We provide the hardware to Sensory Robotics. They handle all the back-end development. What's
Gotcha.
cool about the system is we're able to reach PLD level certification with the blind spot monitoring. The cameras alone are only PLC, but once we fuse that data together, we can reach PLD.
Yeah, and this is all being done over Ethernet. Do you know if the SICK sensors themselves, if those can communicate over like a SIP safety type of network?
Right now, the SICK Safe Vision areas do not communicate over ProfiSafe, SIP Safety. It's all Ethernet and I/O based, OSSD outputs.
Gotcha.
And that's what the system's using today. We're working on getting a new version with ProfiSafe as well.
Yep.
But for now, it's all I/O based safety.
Yeah. Yeah, I mean, and whenever they go to like the SIP safety version, that'll just help add like more flexibility. Then you're able to take in some more of this data that we see here and kind of utilize some of that in the background of the PLC versus using like just discrete OSSD signals. You might be able to get like real-time data of like where this safety zone is at and be able to use it for other use cases, even beyond safety.
Yep.
Maybe to make sure that the robots don't crash into each other. So this is going to open up a lot of flexibility into the future and what you can do with these systems. And also too, even with them being Ethernet based, you can probably still see a lot of that point cloud data and stuff directly from the camera.
Yeah, we can actually see on the monitor up here the point cloud that the cameras are generating.
Gotcha.
That's a nice visualization for what the cameras are seeing. And that way I know when I'm about to enter that safety bubble.
Yeah, you can see your hand entering through there.
I can see myself, yep.
Yep. Yeah, and so, even though it doesn't have like the SIP safety rating, it has the ability to communicate the data and communicate that cloud point to your PLC, so that way you can use it for other functionalities. I don't know that it'd be an actual great use case, but you could even use it as potential I/O. Maybe you have a box that came into the area, and somehow you could set a trigger that if I see something over here in this area, it's a box, I want to go and pick it up.
It's a good thing you mentioned boxes. What's a nice feature of the system is we might have AMRs moving through the robotic cell, and the system can pre-teach what that point cloud looks like for the AMR and not false trip the robot. Much like the pillar here or the table, we can ignore certain data points that the cameras see.
Yeah.
Therefore, it's not false tripping that bubble.
Do you see, what are some other use cases you see these LiDAR cameras used for?
I see this being used in any sort of depalletization, order commissioning, trailer unloading. We can actually mount these robots on a moving AMR and still protect the robot with this dynamic bubble. This system has yet to be released, so we're still investigating different options, different applications.
Awesome.
But we're hoping Q3 of this year for that release date.
Awesome. Well, thank you, Nick. I appreciate you sharing with us.
Thank you so much.